podcast. Today we're going to conquer division, polynomial division. Warm up. Determine each quotient. 1. 9x divided by 3x. Well, x divided by x is 1. 9 divided by 3 is 3. Now, 4x squared divided by 2x can be written as 4 times x divided by 2x. Well, x divided by x is 1. 4 divided by 2, excuse me, 4x divided by 2 is 2x. Okay, and then x cubed divided by x can be written as x times x divided by x. Well, x divided by x is 1. X times x is x squared. Okay, go ahead and finish up the warm-up. All right, let's take a look at the next page. Getting started. X minus r factor. You have analyzed the graphs of the polynomials to determine the type and the location of the zeros. How can you determine the factors of a polynomial given its algebraic representation and one of its factors? 1. Analyze the graph of the function h of x equals x cubed plus 12x squared plus 41x plus 72. Okay. Describe the key characteristics of h of x. Well, the x-intercept is this point right here, which is -8, 0. And the y-intercept is this point right here, which is 0, 70. Okay. The domain of range is -infinity to +infinity and -infinity to +infinity. B. Describe the number and type of zeros of h of x. The function h of x is cubic, therefore it has 3 zeros. There is 1 real zero and 2 imaginary zeros. All right, let's take a look at the next page. Go ahead and mark this page out. All right, let's take a look at the next page. 2.1. Polynomial long division. To solve 0 equals x cubed plus 12x squared plus 41x plus 72, you need to factor the polynomial and use the zero product property to determine its zeros. The fundamental theorem of algebra states that every polynomial equation of degree n must have n roots. This means that every polynomial can be written as a product of n factors of the form ax plus b. For example, 2x squared minus 3x minus 9 equals 2x plus 3 times x minus 3. If 2 is a factor of 24, then 24 can be divided by 2 without a remainder. In the same way, the factors of a polynomial divide into the polynomial without a remainder. Polynomial long division is an algorithm for dividing one polynomial by another of equal or lesser degree. The process is similar to integer long division. All right, let's take a look at integer long division. Okay, so we have 3,660 divided by 12. So using integer long division, we ask ourselves, 12 times what gives us 36? Well, the answer to that is 3. And then we multiply. 3 times 12 is 36. Well, 36 minus 36 is 0, so we bring down the 6. We ask ourselves, 12 times what gives us 6? The answer to that is 0. There is not a number times 12 that would give us 6. So then we bring down 0. Now we ask ourselves, 12 times what gives us 60? The answer to that is 5. So 5 times 12 is 60. Subtract remainder of 0. All right, let's take a look at polynomial long division. So we have x cubed plus 12x squared plus 41x plus 72 divided by x plus 8. So we take x plus 8 and divide it into x cubed plus 12x squared plus 41x plus 72. We ask ourselves, what do we multiply x by to give us x cubed? The answer to that is 1x squared. And now we multiply. 1x squared times x is 1x cubed. 1x squared times 8 is 8x squared. And then we subtract. This cancels. 12x squared minus 8x squared is 4x squared. And then we bring down the plus 41x. Now we ask ourselves, what do you multiply x by to give you 4x squared? The answer to that is plus 4x. And now we multiply. 4x times x is 4x squared. 4x times 8 is 32x. and then we subtract. This cancels. 41x minus 32x is 9x. Bring down the plus 72. And then we ask ourselves, what do we multiply x by to give us 9x? The answer to that is plus 9. And now we multiply 9 times x is 9x. 9 times 8 is 72. Subtract, subtract. Remainder is 0. All right, go ahead and finish it up. Let's take a look at the next page. 1. Analyze the worked example that shows integer long division and polynomial long division. A. In what ways are the integer and polynomial long division algorithms similar? The steps are basically the same. Complex division is broken into a series of smaller division problems. Mark out B. Let's go and take a look at C. Is h of x completely factored? Explain your reasoning. The function is completely factored. The expression x squared plus 4x plus 9 cannot be factored. E. Determine the zeros of the function. F of x equals x plus 8 times x squared plus 4x plus 9. Well, first we said x plus 8 equals 0 and solve, so we subtract 8 from both sides to get x equals negative 8. Okay? Now we set x squared plus 4x plus 9 equal to 0. This isn't a factor, so we have to use the quadratic formula. Well, this is a, b, and c, so we plug those in. So it's negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 9 divided by 2 times 1. Well, that becomes negative 4 plus or minus the square root. Let's go ahead and plug this into Desmos. So that's 4 squared minus 4 times 1 times 9 is negative 20 divided by 2. Well, the square root negative number is imaginary, so x equals negative 4 plus I square root of 20 divided by 2. And x equals negative 4 minus I square root of 20 divided by 2. All right, go ahead and finish up E, and let's take a look at number 2. The expression x minus 7 is a factor of x cubed minus 10x squared plus 11x plus 70. Solve 0 equals x cubed minus 10x squared plus 11x plus 70 over the set of complex numbers. So we go ahead and divide. Okay. So we ask ourselves, what do we multiply x by to give us x cubed? The answer to that is 1x squared. And then we multiply. 1x squared times x is 1x cubed. And then 1x squared times 7 is minus 7x squared. We subtract. We subtract the negative, it becomes positive. Cancels. Negative 10x squared and 7 is minus 3x squared. Go ahead and bring down the plus 11x. Now we ask ourselves, what do we multiply x by to give us negative 3x squared? The answer to that is minus 3x. And then we multiply negative 3x times x is negative 3x squared. And then negative 3x times negative 7 is a positive 21x. We subtract, that becomes positive, minus, cancels, you're left with negative 20x plus 70. Okay, so then we ask ourselves, what do we multiply x by to give us, oh, almost made a mistake. Let's be minus 10x. The answer to that is minus 10, and now we multiply. Negative 10 times x is negative 10x. Negative 10 times negative 7 is a positive 70. Subtract, that becomes positive, minus, cancel, cancel, remainder 0. So now we know that that's a 0, so we set x minus 7 equal to 0. Add 7 to both sides. X equals 7 is one of the zeros. Now we know that this is a, this is B, and this is C. We're going to use these values and the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a to find the remaining two zeros. So x equals negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 10 divided by 2 times 1. So x equals positive 3 plus or minus square root. Let's go ahead and plug that into Desmos. So parentheses negative 3 squared minus 4 times 1 times negative 10 is 49. Divided by 2, which equals 3 plus or minus 7 divided by 2, which we can put that in Desmos. So let's do 3 plus 7 divided by 2, and let's do 3 minus 7 divided by 2. So x equals 5 and x equals negative 2. All right, go ahead and finish up number 2. All right, let's take a look at the next page. The student works 3. So go ahead and finish up your notes, start working on that problem, and have a wonderful Wildcat day.